This is GMAETS 41, your channel of excellence. You're welcome to this live stream class. So in this class, I want us to just briefly discuss the concept of spherical mirror. Spherical mirror, we refer to it also as curved mirror. And there we talk about concave and convex lens. Using this opportunity to work, and I hope that we are warming up as the GMAETS 41 prepares to declare and activate the GMAETS 41's TNA. Let's see how that goes at the end of this class. Please, once you join this class, share the link to your friends, your WhatsApp group, okay, your departmental WhatsApp group, and invite your friends to join this class. Chioma Onyinye, you are welcome. Good evening. Glad to see you. Please give me a moment. I'd like to share the link to the GMAETS 41's group so they will be informed about the class. So let's see. Like I've always told you, friends, if you have not subscribed to this channel, make sure you subscribe now. Turn on the notification bell, select all, so that whenever I come on live like this, you will be personally notified by YouTube. So in this class, we are going to be looking at curved mirror. We'll talk about concave and convex mirror. Concave mirror is also called converging mirror, and convex mirror is called diverging mirror. Now, I had already treated the concept of concave and convex lenses. Yes, if you've been following up with our classes, you will agree with me that we've treated that. And I remember explaining in that class that good knowledge of concave and convex lens, which is the same as diverging and converging lens respectively. You know, if you're talking about lens, concave lens is diverging lens, and then convex lens is converging lens. But if you're not talking about mirror, there is a little adjustment, okay? Concave mirror is our converging mirror, and convex mirror is our diverging mirror. So take note of that difference. I hope you have your learning material with you, your pen, your book, so you put down this difference, okay? Like I said, I'm trying to quickly share this. You too, do your own part, all right? Share the link to your friends so that they can connect to the class and, of course, learn something wonderful. It's going to be a brief class. We hope that network, respects itself so that we would benefit maximally from the class. So, let's see. So, like I said, we'll be dealing with spherical mirror, all right? When you talk about mirror, we try to study the principle of reflection of light. Take note of that. We try to study the principle of what? Reflection of light on mirrors. Now we have plain mirrors, the one we use at home, okay? That which you use to look at your face, plain mirror. And we have curved mirror, also referred to as spherical mirror. Our focus is to deal with curved mirror, because for plain mirror, there is not much tough things there, right? They're just for you to know the characteristics or properties of image formed by a plain mirror, but we'll still talk about that in subsequent classes, okay? So in dealing with our curved mirror, we study the concept of reflection of light, like I've said. And here we give attention to concave mirror, also known as converging mirror. We want to take note of that. So there are two major types of this curved mirror, and then we have our convex mirror, Convex mirror is also known as diverging mirror. Convex mirror is also known as what? Diverging mirror. You could see that the width of the screen is a bit small. Yes, the reason for that is I also give opportunity to have a live interaction with anyone, okay? But hold on, you can request. You can actually request to come on live. I would bring you up live. But let's just move on. That's when you have a question, so you can interact with me. That is why you see the screen a bit small, but I am certain that you can see the board very well, okay? Yeah, I'm certain you can see it. So like I said, if you have any question, you can indicate. You click, I've shared a link already, okay? The link that will help you to come on live with me, and then we can interact. So back to what we're talking about, there are two of these mirrors. We have the concave mirror, also called the converging mirror, and we have the convex mirror, also known as what? The diverging mirror. Okay, when you talk about concave and convex, under lens, they are opposites. In lens, your convex lens is your converging. Your concave lens is your diverging. Does that make sense? So just at least have that in mind. Now, when we talk about this mirror, it's important for us to understand something. That our curved mirrors used to study the principle of reflection of light on curved surfaces. These curved mirrors are actually obtained from a spherical mirror. That is why on the board you see the topic, the spherical mirror. So if I have a sphere, look at this. Let's assume that this is a spherical mirror. Let's assume that this is a spherical mirror. All right. This is my sphere. It's not funny. It's not funny. Anyway, don't mind me. I'll just sketch something on the board. Let's assume that this is our spherical mirror. Let's assume that this is our spherical mirror. I want to draw something that's a bit good. So let's go this way. Let's see if I can get something better. All right, permit me, let's manage this. Let us assume that this is our spherical mirror. All right, now this sphere, I can draw a central line through this sphere. And then maybe I have here to be the center of the sphere. I have here to be the center of the sphere. Let's call it C. Now this sphere has been divided into two, as you can see here on the board. Okay. So if I have divided this sphere into two, clearly you'll be seeing that we have something like this, and we have something like this. Does that make sense? So we have the center as well. We have the center, called the center C, right? Now, if I decide to paint outside, let me say I paint outside, okay? I coat it with something, just like your plain mirror. Just like your plain mirror, the back is coated with silver, right? To help it reflect. So the back is coated with silver. You now have the front where you look at the face. Good. Now with the outside coated, painted, so that it will not reflect. In this case, the inside is the reflecting surface. The inside is the reflecting surface. This type of curved mirror is called concave. It's called what? Concave mirror, also known as converging mirror. Which simply means that for concave mirror, the reflecting surface is inside the curve. Let me assume that I now paint this one. I paint inside here. So I paint inside here, leaving the outside of the curve as the reflecting surface. The mirror in which the outside of the curve is the reflecting surface is called convex mirror. Convex mirror. Remember that your convex mirror is the same as diverging mirror. So this is how we obtain these types of mirror, the concave and the convex. Simply obtain them from a spherical mirror, a sphere. If the reflecting surface is the inside of the curve, we call that mirror concave mirror. If the reflecting surface is the outside of the curve, we call it convex mirror. Permit me to label reflecting surface. Because what we are trying to study here is actually reflection of light, but on a curved surface. Reflecting surface outside of it. And then this, the reflecting surface is inside. Reflecting surface. That's good. Now I have established this concept. We are now going to define certain terms now, what we call mirror parameters. Just like we have lens parameters, we also have parameters that define our mirror for us, okay? Plane mirrors. So I hope you are ready for us to discuss that, okay? Please, like I said, remember, if you have a question, you can come on live, okay? You can come on live. I've already shared the link. I've shared the link, and I've always advised you friends to make use of this platform's community. This channel has a community. If you go to the home page, you will see view community. If you tap on that view community, whatever GMAT 41 updates, you will also see it. So you get the link, and more so, you can become a channel member. Once you become a channel member, send a message to GMAT 41 on this contact. Look at this contact, this one. This is my one and only contact, yes. The GMAT 41's contact for now. So anytime that I add any further contact for you to reach GMAT 41, you'll be notified. Please, for now, this is the GMAT 41's one and only contact. Take notes. Take notes. I don't know what you're seeing here. Don't contact me on this. I don't use it to contact anybody either. So you take note of that. Now this is the contact. So you can become a channel member and then send a message to GMAT 41 on WhatsApp. So you can be added to our WhatsApp group where you can also get information about our classes. All right. Like I said, if you want to come on live, so we can interact when necessary, because you have a link that you need to click in order to be able to be brought live. So we are going to move on to mirror parameters. I've shown you how this mirror forms, okay? But before we move on to defining mirror parameters, please, I want to identify this point called C. This point C is called the center of curvature. Center of curvature. Center of curvature. Maybe you have heard of this before. You may have heard of the name. It's possible. Okay, but if you have not heard of it, I'm telling you now that that C there is called the center of curvature. It's called the center of curvature. Please remember to like and share the link to this video, okay? Leave your comments. Your appreciation comments is highly appreciated. So this C is called the center of curvature. I have a question for you before we start defining mirror parameters. If we call this C the center of curvature, my question is, this center as you're seeing, look at it. Does it belong to one of the two mirrors only? The center of curvature, can you say it belongs to this concave mirror? Or can you say it belongs to this convex mirror? As a matter of fact, the center of curvature, if we are to go into certain analysis, I would simply say that the center of curvature does not belong to any of the mirrors, or it belongs to both mirrors. So what should you know about the center of curvature? The center of curvature belongs to the sphere from which the curved mirrors are obtained. Once again, the center of curvature belongs to the sphere from which the curved mirrors, the concave and the convex mirrors, are obtained from. So you take note of that, okay? The center of curvature, it belongs to the sphere itself. This is your spherical mirror. Let me indicate spherical mirror. So from it, we get these curved mirrors. Okay, so we are done talking about the center of curvature, and I hope you took note of this important point that I have brought out to you. Let us now move on to mirror parameters. I'm going to wipe the board. I'm going to wipe the board. If you want to screenshot, you can screenshot. Or perhaps I might just adjust the camera to the other side of the board. I'll adjust the camera to the other side of the board. What do you think? All right, I'm going to wipe this. So I wouldn't be moving the camera, up and down. Mirror parameters, that's what we want to deal with now. Just like we have lens parameters, we also have mirror parameters. There are lots of relationship between, this concept of lenses and the curved mirror. That's why I am usually making reference to lens. If you have good knowledge of convex and concave lens, then you've learned also a lot about mirrors. The only thing is that lens is used to study refraction of light, the bending of light. All right? While mirrors are used to study reflection, the ability of light to bounce back after it hits a surface. Mirror parameters. Mirror parameters. Mirror parameters. Now, permit me, because for the purpose of studies, we usually focus more on concave mirror, that is converging mirror. The reason is because this mirror can form certain kind of image, all right, real image in almost 99% cases. In almost 99% of the position of the object, concave mirror forms a real image. It's only in one position that it forms a virtual image. For that reason, we usually focus more on concave mirror when analyzing. Convex mirror forms only one type of image, which is a virtual image. Okay, virtual image. Okay, the image is virtual, it's erect and magnified. Yeah, that's the type of image that concave mirror usually forms. They magnified or diminished, as the case might be. All right, diminished. For convex mirror, convex. Concave mirror forms a real image. Okay, concave mirror forms what? Real image. And the size of the image can differ. That is why we focus on that. Let me sketch this, and we assume this to be our concave mirror. Remember, how do you identify your concave mirror? The reflecting surface is the inside the curve. So we are going to paint outside. And once you see this thing, we use it to mean that you painted, all right? Yes, you polished the outside, okay, of the curve. So the reflecting surface is the inside. Now, permit me to label this point as point A on the curved mirror, and here point B. Permit me to label here the center, okay? The center, I'm going to label it as P. I'm going to label it as what? P. Then permit me to draw a straight horizontal line. A straight horizontal line, let's see. A straight horizontal line that passes through, good, that passes through this point P. All right. So with this, I can talk about the mirror parameters now, as you are expected to know. All right. So I will label here as small letter f. Then I'll label here as capital letter F. Okay. Here is capital letter F. Then I don't need to label here. Good. Then let me label this point as C. I'm going to adjust this F a bit. I just want to time something or target something. So F here. Good. I'm satisfied. I'm satisfied. So look at this diagram. We are going to use it to now introduce the concept of mirror parameters. So what are the parameters whenever you're discussing, mirror, your curved mirror, all right, or spherical mirror as you can call it, concave and convex. One of it is what we call the aperture. Aperture. This is one of our mirror parameter, the aperture. And what is the aperture? You can put it down because I'm not going to copy it on the board. This is a live class. I don't have that time to be copying all these things on the board. If it were to be a pre-recorded video lesson, I would have written on the board and or, use our normal teaching tool to write a short note on the board where you can see. Now that it's live class, follow along so we'll be able to conserve time, okay? Aperture. Aperture of a mirror is defined as the width of the mirror. As the what? Width of the mirror. So let me just write width of the mirror. Be it concave or convex lens. Be it concave or convex. The aperture is the width of the mirror. So the width of the mirror is this width AB. Are you getting me right? This width AB. That is what we call the aperture. All right. So if the mirror spans from this point to this point, all right, something like this. So this would be the aperture, that width. The second mirror parameter I would like you to know is that which we call the pole. The pole. That pole, think I can actually use these things to define them. I hope this part didn't cut off. Let me check. I hope it didn't cut off. I want to use the labels on the board to also be defining it for you so you can see them clearly. Let me check that this does not cut off. All right. So it's showing up, right? Let me write AB just under it. That with AB. That's what we call the aperture. So pole, we're going to use P to represent it. So you know clearly what the pole of a mirror is. Look at the center of that mirror, be it concave or convex mirror. The pole of a mirror is the center of the mirror. The center of the mirror. That's what we call the pole. We use P to represent it. Now, I want to tell you something. In the study of mirror, we call the center of the mirror the pole. In lens, the center of the mirror of the lens is called optical center. Optical center in lens and pole in what? In the study of curved mirror. So take note of them because an examiner can ask you what is the corollary of optical center in mirror, right? Or which of the following represents or replaces pole in lens? You talk about pole in the study of curved mirror, and you talk about optical center in the study of what? Lens. So you take note of that. And that point is very important to us. It is. Let us go to the third one. We are going to define the next point called the center of curvature. The center of curvature. Center of curvature. That's another mirror parameter that you are expected to know. So center of curvature, we use C to represent it. And the center of curvature, look at it, is simply the center of the sphere of which the mirror forms a part. Permit me to indicate of the sphere. Of the sphere. Good. Of which the mirror forms what? A part. That is why I actually drew your attention to something before I wiped the diagram from the board. that spherical mirror diagram from which we obtained the concave and convex mirror, I asked you this question. That C, that center of the sphere, does it belong to the concave mirror or to the convex mirror? And I said something that it does not belong to any one of them. Or if we must say, because okay, it belongs to both of them. It is important for you to know that the center of curvature actually belongs to the sphere from which we obtained the mirrors. So in defining the center of curvature, it is simply the center of the sphere from which the mirrors are obtained. Does that make sense? And I want you to take note of something. This is simply telling us that look at this C. If this is the center of curvature, then maybe you have to complete the sphere from which you get this mirror. You have the other part of it here. You have the other part of it here. That's what we're talking about here, okay? Good. And now, before we move on quickly, let me show you something. Assuming that this is the sphere, let us assume that this is the sphere, because we're going to define the next term, the radius of curvature. The radius of curvature. I've defined the center of curvature. Let us assume that this is the sphere. And then this is the center of curvature, which of course happens to be the center of this sphere. What would be the radius of curvature? The radius of curvature is the length or the distance from the center of curvature to the pole. The distance from the center of curvature to what? To the pole. It is just like you talking about the center of a circle. It is just like you talking about the center of what? A circle. And you know that the distance or length from the center of a circle to any point on the circumference of the circle is called the radius. In the same way, in the study of mirror, the distance, the length from the center of the sphere from which the mirrors are obtained from, that distance, that length from the center to the pole specifically is called the radius of curvature, which means the length from C to P here is what we call the radius of curvature. That, of course, is the next parameter we want to talk about. Radius of curvature. Radius of curvature. We use small letter r to represent it, and it is simply put, the radius of the sphere. The what? The radius of the sphere from which the mirrors are obtained. The radius of the sphere from which the mirrors are obtained. And of course, I would like to show you the mathematical representation or significance of the radius of curvature. The radius of curvature from our diagram here is equal to CP. Is equal to what? CP, the length from point C to point what? P. And let me open your eyes to something. Because radius of curvature is simply a length, distance between how many points? 2 points. An examiner has the right to ask you a coordinate geometry related question under this lens or under this mirror. All right, I'll give you an example. I had already taught something like that under lens. If I give you the coordinate of this point C, let's say 2,5, and I give you the coordinate of this point P, let us say 1, -3, whatever I want to give to you as a number. With the two coordinates of these 2 points, you can calculate the radius of curvature. And the radius of curvature is very important to us. It's very important to us. Don't worry, we are moving on. We are moving on. I would have given you, don't worry, when we define the next mirror parameter, I will now bring in the relationship between the radius of curvature and the next parameter we are going to talk about. This time, we want to talk about the principal focus. Principal focus. The principal focus of a mirror. Principal focus of a mirror. Now, in our diagram, that is the point, capital F. That is the point, capital F. So what is the principal focus of a mirror? It has not changed. It is still the same as defining the principal focus of a lens. The only thing now is you don't use lens, rather you use what? Mirror. So the principal focus of a mirror is that point on the principal axis. Is that what I said? Point on the principal axis. Now we're going to talk about principal axis, but why waste our time? I've defined some of these concepts or terms under lens. The principal axis is this straight line that passes through the pole, connecting the center of curvature to the pole. This straight line, that's the principal axis. So the principal is a point on the principal axis where rays of light appears to converge in the case of concave mirror, or diverge in the case of convex mirror after being reflected by the curved surface. The point on the principal axis where rays of light appears to converge, to meet, or appears to diverge, to scatter away from, after the ray of light is being reflected by the curved mirror. Now, when we talk about rays of light converging, that is for concave lens, for concave mirror rather, because concave mirror converges light. While convex mirror, the principal focus of a convex mirror is the point where the ray of light diverges from. I hope I'm communicating right. That's good. So we've defined this principal focus, and take note, like I said, the principal focus is a point, a point. Don't forget, the pole is a point, a point. The aperture is just a width, okay? Just that this is a curve, width along a curve. It's not purely a straight line. It is a width along what? A curve. The center of curvature is a point, is a point. The radius of curvature is a distance. In fact, let me show you here. I think I can wipe this stuff I drew here. The radius of curvature is this distance from here to the pole. Permit me, please, to take this line from here, something like this. So this is our radius of curvature. I'm sorry, the pole only appears at one point of a mirror, which is this point. Which is this point. I'm sorry that I had to bring, just to define that radius of curvature, I had to bring this tracing point here. If it will be this tracing line here. It's not meant to be. Normally, the length from here, this specific point, the pole, to the center of curvature is what we call the radius of curvature. I hope we are learning, right? If you have a question, remember, you can ask your question. You can ask a question. Chidube Okonkwo, great teaching. Thank you very much. I appreciate that. Okay, you can ask your question, and then you on the things that I'm explaining. I'll give room for that. You would interact. Okay, so where are we? We've just defined the principal focus. This point is a principal focus. All right, it's a principal. That straight line which connects the center of curvature towards to the pole. Now it is the line lines that is parallel to it, however, does not pass through it. Let's assume a ray of light goes this way. If the ray of light falls on this mirror, it will reflect to this point. But if any ray of light passes through this principal axis, it won't reflect. And like I said, it is the line through which if a ray of light passes, that ray of light will not reflect. Already you're following up, can screenshot. Okay, you can copy, but of course to be fast is screenshot. Should I write number 7 on top here? Let me write it here. Radius of curvature. So think I'll define radius of curvature. We're talking about the focal length, rather. Focal length. Focal length. The focal length, we use letter F for it. Just like you have the name, focal length. Length. The focal length is simply a length or distance between the principal focus and the pole. The length, the distance between the principal focus and the pole. So you see that the definition of focal length of a mirror has not changed. It is still similar to that of lens. Because in lens, I remember that the focal length of a lens is the length or the distance between the principal focus and the optical center of that lens. Remember that in mirror, the optical center is now called the pole. So the distance between the principal focus focal length. Good. Focal length. Somehow, some way, by analysis, it has been found that the focal length is half of the radius of curvature. I repeat, the focal length is half of the radius of curvature, which means the radius of curvature divided by 2 is going to give you the focal length of a mirror, be it concave or convex mirror. Take note of that. You see this length from the principal focus to the pole is half of the length from the center of curvature to the pole. So for that reason, we can say that F is equal to R over 2. That F, okay, F is equal to FP. FP. And mathematically, it is the radius of curvature divided by 2. Very powerful relationship. Take note of that. You know, in mirror calculation, the mirror formula is similar, in fact, the same as length formula. And whenever you're dealing with this formula, you need your focal length. Very important. Very, very important. That is why you don't joke with this. To get the focal length, it is the radius of curvature divided by what? 2. And don't forget that the radius of curvature is still the same as the distance measured from the center of curvature of the sphere that produced the mirror. The distance measured from that center of curvature to the pole of the mirror. So that distance, that length is our radius of curvature. If you divide that length by 2, you will get your focal length of that mirror. And once you get the focal length of a mirror, of course, you can now use that idea with mirror formula to play with the image distance and the object distance V and U, respectively. Is there any other parameter to be defined? I really don't think. I think we are done defining all our mirror parameters of interest. So, as a quick summary, aperture is just the width of the mirror. The pole is a point on the mirror. And what is this point? The center of the mirror, be it concave or convex. The center of curvature is the center of the sphere that produced the mirror. The center of the sphere where the mirror was obtained from. And when you talk about the center of something, is a point. So you take note, aperture is width, pole is a point, C, that is center of curvature, is a point. Then we now have radius of curvature. Radius of curvature is the length, the distance from the center of curvature to the pole of the mirror. So here we are talking about distance. Take note. I am very particular about this because an examiner can just try to drip you using the knowledge of coordinate geometry. Okay? Don't worry, in our next class, when we solve questions on this, you are going to learn more about how an examiner can give you questions on this concept of mirror. But one significant thing about mirror and its calculation or analysis is that once you know a lot about lenses, concave and convex lens, you've actually learned 95% to 99% of the concept of curved mirrors. Radius of curvature, we said, is the radius of the sphere, all right, from which the mirrors are obtained from. It is also defined as the distance from the center of curvature to the pole of the mirror. So you see that is length. Then principal focus. Principal focus is a point on the principal axis. In fact, for a formal definition, we define the principal focus as a point on the principal axis where rays of light parallel to and close to the principal axis. I take that again. The principal focus is a point on the principal axis where rays of light that are parallel to the principal axis and close to the principal axis will appear to converge or to diverge from. Let me get this. Anyway, it doesn't matter because I think the color of the marker will still show. I want to use blue. I want to use blue to show you what I mean by that. That the principal focus is a point on the principal axis where rays of light that are parallel to the principal axis. Now watch. This ray of light is drawn to be parallel to the principal axis. Look at another one. Is drawn to be parallel to the principal axis. So the principal focus now is a point on the principal axis where rays of light parallel to and close to the principal axis will appear to converge after they reflect. Appear to do what? Converge. Observe something. This ray of light, as they hit this reflecting surface, it converged to the principal focus. The same thing with this one, it converged here. In the case of convergence of light, you know that gives you your concave mirror. However, assuming that this is convex mirror, where the reflecting surface is now the outside, inside is coated, inside is polished for convex mirror. Okay, so we say that outside is the reflecting surface. In that case, the mirror will go this way. Something like this. I will say the rays of light will now come this way, but let me just draw it this way, like this. Okay. So as the rays of light, this is the principal axis. As the rays of light move this way, okay, they will, if this is the principal focus, they would meet at this principal focus and then diverge from that point. This is for convex mirror, But we don't have much problem with this analysis because it forms only one image. Like I said, one type of image, which is virtual, erect, that is upright, and diminished. This is the mirror. Yeah. So the inside is polished. The outside is a reflecting surface. The image will form somewhere on the other side while the object is here. All right, I think I just tried to give further definition or clarity to the principal focus because you might get to the formal definition as a point on the principal axis where rays of light that are parallel to the principal axis and close to the principal axis, where those rays of light will appear to converge or what? Diverge. I don't want to stretch this line, this one, I don't want to stretch it. If I take it out, I am now saying that this is a convex mirror. because in convex mirror, the light will diverge. All right, so that takes us to the principal axis. The principal axis is just a straight line that passes through the pole connecting the center of curvature. And finally, the focal length. The focal length is the distance, the length between the principal focus and the pole. And that focal length is simply half of the radius of curvature. In mirror studies, we don't have anything called power of the mirror. We don't talk about that. Remember, in length, we have power of length, okay, which is 1 over focal length in the unit of diopter. That is for length. In mirror, we don't have anything as that. I have delivered this lecture. What have we done so far? We talked about how we obtain our curved mirrors. How do we obtain them? We obtain them from our spherical mirror, just as if the spherical mirror is cut into 2 equal parts. So each of them can be used to produce our curved mirrors. If you want to get a concave mirror, then you are going to polish the outside of the curve. The inside will now become the reflecting surface. That gives the concave or converging mirror. We learned that if the mirror is now diverging or convex mirror, then the inside of the curve will be polished. The outside will now be the reflecting surface. Are you following, right? The outside will now be the reflecting surface. And then we went ahead to define our mirror parameters as we have here on the board. Now, taking these to be our concave mirror or converging mirror, pay attention to this. You can put it down. For all positions of objects, what? Objects. A concave mirror, which is also called converging mirror, will form real image, inverted image. Will form what? Real and inverted image. Where we now have this concept of, okay, let's talk more about it, is the size of the image, the size. Will the image be diminished? Will it be the same size as the object, or will it be magnified? That now depends on the position of the object. Remember what I said, this mirror forms real image and inverted image, real and inverted. Concave mirror, converging mirror, forms real and inverted image for all positions of the object, except in one position. Except in one position. But before I talk about the exception, remember I didn't talk about the size of the image. I didn't tell you that the image is always diminished. I didn't tell you it is always magnified. I didn't tell you it is always the same size as the object. Why I didn't say anything is because, anything as that, is because the size of the image depends on the position of the object. But in terms of whether it forms real or virtual image, okay, concave mirror, also called converging mirror, forms real image and inverted. Take note of this. If you link it to length, because converging mirror, right, which is called concave mirror, under length, that guy becomes convex length. Convex length is the converging there. So if you had taken the lecture on lenses, 98% of the things I explained under converging lens, which is convex lens, is the same as what you have in concave mirror, which is converging mirror here. Am I communicating? See, if you learn the right way, you will love it. Someone that has taken lectures on lenses very well and you understand it, much of what I'm saying here would just be like a revision class. Now, if this guy forms real image in almost all cases, like I said, except one case, under which condition will concave mirror now form a virtual image? Virtual image, and in that case, the image will be erect. It will no longer be turned upside down. It will no longer be inverted. That happens if the object is placed between the principal focus and the pole. If you place any object between the principal focus and the pole, are you following, right? Any object placed between the principal focus and the what? The pole. that object, the image the concave mirror will form will be virtual image and upright, that is erect. That image in that case will form behind the mirror, or you can say beyond the mirror. You have the object here. The object is placed here. Look at here. You place the object here between F and P. The image of this object will be formed beyond the mirror, on the other side of the mirror. This is the only case where concave mirror will form a virtual image and upright image. It will be magnified. The image will be magnified in that case to be bigger than the object. But remember, in terms of the size, I'm not talking much about the size because it is not only in this position that the image will be magnified. Image can be magnified also at some other positions. All right. If you place the object before this principal focus, say somewhere here, anything from here this way until before you cross this F, all these positions of objects, the image will be real and inverted. The image will be what? Real and inverted. If the object is here before C, take note of this, let me just quickly analyze it. If the object is here, that is before C or greater than C, because we take measurement from the pole. We take measurement from the pole. So if object is placed beyond the center of curvature, the image will be formed in front of the mirror, somewhere here. Okay? The image will be inverted and diminished. It will also be real. Take note, that is object placed beyond this C. The image will be real, inverted, and diminished. The image will be formed in front of the mirror here. If you bring the object to the center of curvature, the image will be real, inverted, and then the same size. The same what? Size as the object. If you shift this to any point between C and F, again, the image will be real, inverted, then it will start getting magnified. So you see that this point C is the boundary between when you get diminished image and when you get what? Magnified image. At this point C, the image is the same size as the object. So the magnification will be 1 there. And once the object now moves to between principal focus and pole, somewhere here, the image will become virtual, upright, that is erect, magnified. And then the image will no longer be in front of the mirror. Rather, it will go beyond or behind the mirror. That is for concave mirror. For convex mirror, you don't have problem. All the images formed by this guy, convex mirror, is virtual, erect. Now, I think diminished also. All right, so we are done with this concept, and I hope you've learned something cool from this class that will guide you as you prepare for your examination. All right. Okay, so if you have any question, you can prepare to ask. If you have any question, you can always prepare to ask. Out of these two mirrors, which one is used as our shaving mirror? The one we use as our shaving mirror is concave mirror, which is converging mirror. All right, that's the one we use as our shaving mirror. Mirror formula. Mirror formula. Mirror formula. Let us conclude with mirror formula. Mirror formula is the same as lens formula. Is that okay? Mirror formula is the same as lens formula. We're done with mirror parameters. So now talk about mirror formula. So mirror formula is 1 over F equal to 1 over U plus 1 over V. So take note of this. Then what is our magnification? Magnification M is equal to the image quantity divided by the object quantity. This is image distance over object distance, or image position over object position for the mirror. And this guy is also the same as the image height over the object height, or the image size over the object size. Whenever you're talking about magnification, like I explained on the lens, it is all about the image quantity over the object quantity. Take note of that, because under pinhole camera, we still have this magnification formula that relates the distance of the object to the pinhole and the distance of the image from the pinhole, where in that case you will have the formula to the magnification equal to the length of the camera, which is equal to the distance of the image from the film to the pinhole of the camera, divided by the distance of the object away from the pinhole of the camera. Don't worry, when we talk about reflection on plane mirror, you would learn that. So now just know generally that magnification is image quantity over what? Object quantity. I've established the key things you need to know when studying your what? Mirror, curved mirror, reflection on curved mirror. In the next class, we're going to deal with calculations. But like I said, if you understand calculations on lenses very well, this guy will be 1 plus 1, because the calculations are as much as 98% the same. I hope you love this class. If you have any question, you can ask. Like I said, I'll be seeing you in my next class. We're meeting in our next class, all right? However, with this particular class being brought to an end, and with respect to the fact that many of our students will be sitting for the examinations or have even started in some courses, the GMAETS 41 hereby declares open the GMAETS 41's total non-stop action. The academic firepower is now activated after being on high alert. So make sure you stay tuned, because almost daily I will be running classes with respect to exam-focused revisions in the following courses: physics, chemistry courses, and maths courses. From Wednesday, we are going to kickstart this. From Wednesday, we are going to kickstart this. I think Wednesday is, today is 28, right? I think Wednesday will now be 30. So on Wednesday, we're going to kick off the GMAETS 41's exam-focused revision, where we prepare our students, our scholars, for what? A splashes, where we coach you to go in there and get us that A splashes which you deserve, because you can do it. You can do it. Together, you can blast that first class, for it is very possible. I'll be seeing you tomorrow. Have a good night rest.